In the figure, you are having a 3-winding transformer with the windings named 1, 2 and 3, and the transformer is wound on a same core as shown. And the turns ratio of 3 windings are given as 4:2:1, and the resistor at second winding is 10 ohms, and the reactance, capacitive reactance at third winding is given as 2.5 ohms. Now it is given that the primary is connected with a 400 volt supply, so we are supposed to find the value of I which flows through this supply. In such types of question, you should always think about what we have to find, and after that we have to think the data given by them. Here we need to find I1, hence for finding I1 we are going to use MMF balance rule, which says the MMF across the winding always remains constant, that is N1 I1 is equals to N2 I2 plus N3 I3. By this we can find I1, which is N2 divided by N1 into I2 plus N3 divided by N1 into I3. But for that we need I2 and I3, and for finding I2 and I3 we need V2 and V3. Again, for finding V2 and V3 we are going to use a concept that voltage per turn is always same. That is V1 by N1 is equals to V2 by N2, which in turn equals to V3 by N3. Now we can find V2, which is N2 by N1 into V1, and for the ratio of N1, N2 and N3 we have it as 4:2:1. On substituting this value, we can get the value of V2 is equals to 2 divided by 4 into 400, that is 200 with an angle 0. Now similarly we can use the same concept for V3, which is N3 divided by N2 into V1, and we get our answer as 100 angle 0. Now we can find I1 using the simple Ohm's law. Now at winding number 2 we have resistance whose value is 10 ohms, and using this we can find the value of I2, which is V2 divided by 10, which is 20 angle 0. But at winding 3 we have capacitor of reactance 2.5 ohm. But since it is a capacitor, we always remember a fact that for capacitor current leads voltage by an angle 90, and for inductor current always lags voltage by an angle 90. So that means for capacitive reactance we always use minus J, that is minus JXC. And in case of inductive reactance we use JXL. So using this concept we can find the value of I3, which is V3 divided by Z3, and this Z3 is minus J2.5. Now using this we can find the value of I3, which is 40 angle 90 or J40. Here we have to remember the fact that when minus J goes from denominator to numerator, its sign will be reversed. Now using the same MMF balance rule we can find the value of I2, which is 2 by 4 into 20 plus 1 by 4 into 40J. Now on solving this we get our answer as 10 plus J10. That means our answer should be option C.